Today's video is going to be on number sets, or sets of numbers. First, I wanted to start off with a quote that says, "Most people spend more time and energy going around problems than in trying to solve them." In order to understand mathematical problems, we need to understand the language of mathematics. What is the language of mathematics? Well, it's going to be the sets of numbers, or numbers kind of in general. This video will kind of give you a little story on how we came to each set of number, so hopefully you gain a little bit of a deeper understanding of why and how we came up with the mathematical system which we use. Picture the Middle East 100 centuries ago. Farmers, cattlemen, and tradesmen used tokens and markers to count, to signify a single sheaf of grain, a head of livestock, or a length of cloth. This ingenious system facilitated commerce, paving the way for improved communication and the spread of civilization. This is where we derived our set of natural numbers, the numbers used for counting. These would include 1, 2, 3, 4, 5, so on and so forth. Now fast forward a few thousand years to ancient Egypt. Fractions made their debut, initially as reciprocals and later as representations of quantities divided into equal parts. The Egyptians laid the foundation for more sophisticated mathematical concepts. Really what they had given us was the set of rational numbers, which includes fractions written as terms such as m over n, where n is not equal to 0. Now for the Egyptians, they didn't have a way to represent the idea of 0, so they didn't have to worry about a division by 0, which in our case is the letter n, which would give us an undefined answer. Moving along a little bit in history, imagine a time when there were no cattle to trade or when floods wiped out entire crops. How would one express the existence of nothing? It wasn't until the 5th century AD in India that 0 was introduced to the number system, becoming a crucial number in calculations. This also gave us the set of whole numbers, which is just the natural numbers 1, 2, 3, 4, 5, so on and so forth, with the addition of 0, or the ability to represent nothing in our calculations. However, after this, we found out that numbers needed to represent a loss or a debt. In 7th century India, negative numbers emerged as solutions to equations and tools for handling commercial debts. The introduction of negative numbers expanded the number system, revealing the duality inherent in mathematical representation. What this really means is that in the 7th century, we devised the set of integers, which just adds the negative natural numbers to the set of whole numbers. So now, not only do we have 0, 1, 2, 3, 4, 5, so on and so forth, we also have -1, -2, -3, -4, -5, so on and so forth. After discovering the set of rational numbers, we also determined that there were a set of irrational numbers, which is just the set of numbers that are not rational, are non-repeating, and are non-terminating. Next, I just wanted to show this little kind of graphic that shows how we build on the natural numbers, the 1, 2, 3, 4, 5, 6, 7, 8, 9, so on and so forth, moving on to the whole numbers, which gives us the addition of the 0 number, then up to the integers, which now includes negative natural numbers, how we can represent things as fractions with the rational numbers, and on the outside of the rational numbers are the irrational numbers such as pi, square root of 2, and the number e, etc. I hope this brief history was a little bit of a help in understanding how we developed the different sets of numbers or number sets and the ways in which they can be used a little bit. These are really the foundations of mathematics, and if you can understand these basic concepts, it will become much easier as you progress through your mathematical journey. In the next video, I want to go through a little bit of classification examples, so we'll be able to determine which numbers kind of fit in natural numbers, whole numbers, integers, in the rational number set, or the irrational numbers.